Now we are going to start another topic here, factorization of a polynomial. Okay, that what is the factorization of a polynomial means? Okay, first we'll start with the factor theorem. Okay, now if everybody remember, then the remainder theorem. In the remainder theorem, what it was that a polynomial px is there, which where n is a polynomial of degree n. Okay, this px is a polynomial of degree n whose degree is greater than or equal to 1. Then what happens? What is the remainder? The remainder of this polynomial is, if it is divided by x minus a, then the remainder will be pa. Okay, understood? The remainder will be pa. Now, what is here in factor theorem? If let px be a polynomial of degree n greater than equal to 1 and a be any real number, first condition, if p is equal to 0, then x minus a is a factor of px. Okay, the same theorem is there, only the remainder theorem. Only thing is there in remainder theorem, there was remainder. That means the polynomial that you were dividing, x minus a, is not the factor. Now here it is a factor of the polynomial. That means the remainder will be 0. Yeah, a number is a factor. Like if gx is a factor of, if gx is a factor of px, that means rx will be equal to 0. Yes, the remainder will be 0. The same thing is here. Okay, if px be a polynomial of degree n greater than equal to 1 and a be any real number, then pa, okay, pa will be equal to 0. Then x minus a is a factor of px. If pa is equal to 0, that means x minus a is a factor of px. The second thing is, if x minus a is a factor of px, then pa will be equal to 0. Okay, now let's see the proof. Okay, for first one, that pa is equal to 0. Okay, factor theorem. Just a minute. Factor theorem. Okay, now if you see the factor theorem, the first one. Now the first one, what does say? If pa is equal to 0. Okay, if p is equal to 0, then x minus a is a factor of px. Okay, if pa is equal to 0, then x minus a is a factor. Now how can you prove that? Okay, now here it is given that px is there. Okay, you need to divide px from which value? Divide by x minus a. Okay, yeah. Okay, and from remainder theorem, what we know that px is equal to x minus a gx, not gx qx. You can represent from qx. Okay, so that you're not confused. Okay, here qx is the quotient. Okay, the quotient value when you are dividing from x minus a. When you will divide px from x minus a, qx is the quotient value plus pa. Okay, if you remember from the remainder theorem, the remainder is pa. Okay, now since it is given to you in the question that p is equal to 0, so that implies that px is equal to x minus a qx. Okay, now from this statement, you can say that x minus a is a factor. X minus a is a factor of px. Understood? Okay, now here I have written pa from the remainder theorem. If you remember the remainder theorem, that if px is there, which is divided from x minus a, then the remainder will be pa. The remainder will be equal to pa. So from there I have written px is equal to x minus a qx plus pa. And since pa value is already given to you in the first part, that pa is equal to 0. Okay, pa is equal to 0. That's why, so if pa is equal to 0, so we got px is equal to x minus a qx. So from here it is clear that x minus a is a factor of pa. Understood? Now let's see the second part. What does the second part say? That if, that is the opposite. If x minus a is a factor of px, then pa is equal to 0. Okay, now how can you say that? Just the second part here. Just below this, we'll see the second part also. Okay, if x minus a is a factor of px, then pa is equal to 0. Now, if x minus a is a factor of 0, see from here only, px is equal to x minus a gx. Okay, since x minus a is a factor of px, that means remainder will be 0. So it will be equal to px is equal to x minus a gx. Okay, gx here is the quotient, or you can write qx also. Okay, now it is a factor. That means we can write px is equal to a minus a gx. Okay, so a minus a will be 0 gx. Okay, so what you got? Pa. Okay, so it will, pa will be equal to 0. Okay, so hence we have proved that if both the result has been proved that if pa is equal to 0, then x minus a is a factor of px, and if x minus a is a factor of px, then pa is equal to 0. Okay. And what we conclude from all this, that if x plus a, you can say if x plus a is a factor of px, then p minus a will be equal to 0. Okay. If ax plus b is a factor of px, then p b by a is equal to 0. Okay. If x minus ax plus b is a factor of a, then p is equal to 0.
Ma'am, can you show the sum how to do?
Yeah, of course. We are moving on this. Okay. Different types of problem based on factor theorem. Okay, so there will be two types of problem that you will be seeing here. Sometimes it is given that the 0 is already given to you, that this is a 0 of the polynomial, and then there's some unknown value in the polynomial itself, so you need to find out. Or sometimes it is given that polynomial is given, you need to find out that this particular another linear polynomial is a factor of the given polynomial. Okay, let's see. Now,
ma'am, the previous question px is given 0 from before.
In which previous question?
Ma'am, the question which you made us before this.
This was the theorem, factor theorem. Right now, what I was explaining, this was a factor theorem. Here you can see this is a factor theorem. You need to know the conditions of the factor theorem. Okay, you are going to use this factor theorem to solve the problems. Okay, and this is the proof of the factor theorem that I explained right now. Here, here. Okay.
Okay, I understood, ma'am.
Understood? Now let's see example number 1. Here it is given you that example 1. Okay. Now if x minus a is a factor of 4x square minus mx minus na. Okay. Now you can see here in the polynomial 4x square minus mx minus na. A is not given to you. A is a you can say here it is a is being treated as a variable. Value is not known. You need to find out the value of a. Okay. But it is given that x minus a is a factor of this polynomial. Since x minus a is a factor of this polynomial, that means you need to find out the 0 of x minus a. The 0 of x minus a will be what? X is equal to a. So you need to find out PA. PA, I am writing PA because I am assuming that this is PX. Okay, I am assuming that this is PX. So PA should be equal to 0. Okay, since x minus a is a factor. So what I will do, PA will be 4a square minus ma minus na is equal to 0. So from here, what you got? 4a square minus ma minus na is equal to 0. So if you take a common, so it will be 4a minus m minus n is equal to 0. So a will be equal to m plus n by 4. And I think you have proved it. A is equal to m plus n by 4. So understood? Sometimes this type of question will come that one value in the polynomial is not known. And it is given to you that this particular polynomial, this particular linear polynomial is a factor of the given polynomial. So from there, you need to find out, from this information, you need to find out the value that is not known. Okay, understood everybody? And how you are going to do? Since it is a factor, you already know it's a factor. That means you need to find out the 0 from there. And like here, it is x minus a. So PA will be equal to 0. And when you will equate it to 0, you will get the value of the unknown. Let's see some more problems based on this. Okay, now question example number 2. Find the value of P if 2x minus 1 is a factor of this. Now everybody try to do this question.
Ma'am,
Okay, the question is here. Find the value of P if 2x minus 1 is a factor of 2x cube plus px square plus 11x plus p plus 3. So here px.
we have to keep x as 1 by 2.
Yeah, because 0 of gx is 1. Here gx is equal to 2x minus 1. Okay, so the 0 of gx is 1 by 2. See, 2x minus 1 will give you 1 by 2. So you have to put p 1 by 2. And if you put p 1 by 2, then you will get 5p plus 35. The main basic steps I have already done. You just need to put the value and find out. Since gx is a factor, the 0 of gx will be x is equal to half. So you need to find out the value of p at half. So you will put half instead of x in complete px, and then you will get the value of p. Since it is a factor, so you will be equating p half to 0. So you have to do this much. You have to put the value in this equation, and you'll get the value of p. Who has done it? So what is the equation that you got?
-7.
What? Yeah, minus 7.
-7.
It will be minus 7. Anybody else?
No, I also got minus 7.
Yeah, I also got minus 7. That's good. Okay. So everybody else, those who have not got, you can try and you will get the value of p as minus 7. Okay. So from here, I think you understood that how this type 1 question are solved, everybody. Okay. Now, find m and n if x plus 1. Okay. Now, question number 3, we are not doing just little explanation. Okay. Find m and n. Here, two values are not known. Okay. M and n. Okay. If x plus 2 and x plus 1 are the factor of the given polynomial. Now, two values are not known, and here it is given to you also that x plus 2 is a factor of the polynomial and x plus 1 is also a factor of the polynomial. That means you will form two equations. What? From this, what you will do? You will find the value at f. See, x plus 2 is a factor of the polynomial. So you need to find the value at f2. I'm assuming that this is fx. So you need to find out the value at f2 and you need to find out the value at f1 also. Sorry, minus 2 and minus 1. Because x plus 2 is a factor, x plus 1 is a factor. And when you will find the value at f minus 2, f minus 1 and equate it to 0, since it is a factor, then you will get two equations. And by solving both the equation, you will get the value of m and n. Okay? You will get these questions in the assignment also. Arham, are you confused?
No, no.
No? Okay. So Razi, Shazan, everybody, Advika, Zikra, everybody understood how you're going to do this question?
Yes, ma'am, I understood.
Yeah, that's very good. How we did the question number 2, same way you're going to do this also, only this two equations will be formed. Two values are given, two factors are given, so you will form two equations. Okay. Now, type second. Okay. What is type second? That you need to check that the particular polynomial is a factor or not. Okay, this type of question can come. Now, if you see example number 4, using factor theorem, show that x plus 1 is a factor of x to the power 19 plus 1. Okay, that is not given that this is a factor. You need to check that this is a factor or not. And this is very easy. How can you check that a given number is a factor or not? Okay, how can you change that this is a factor? Check that this is a factor or not by assuming, by putting the value that this C here, px is equal to for 4. Px is equal to x to the power 19 plus 1. And here gx we are assuming, we are letting, okay, that gx is equal to x plus 1. Okay, so this you have to check that gx is a factor or not. So the 0 of gx is what? 0 of gx.
Minus 1.
Yeah, x
Plus
minus 1.
1
So you need to find out the value of p minus 1. If it is equal to 0, then it is a factor. Else it is not a factor. So p minus 1 will be what? Minus 1.
0. Plus 1.
So what?
19 plus 1.
Minus 1 plus 1.
Yeah, because power is negative, so here it will give you negative number. So it is 0. So that means therefore gx. Therefore gx is a factor.
Gx is a factor.
Factor of px. Okay. Since you got p minus 1 is equal to 0. That's why gx is a factor of px. Okay. Let's see some more questions also on this type. Okay. Now, as you understood about the factor theorem, now let's see factorization of a quadratic polynomial. Okay. Now, when we are factorizing a quadratic polynomial, okay, it will not tell you in the question that we are factorizing quadratic polynomial. By looking at the polynomial only, you can tell that it is a quadratic polynomial or a cubic polynomial or a linear polynomial. Just a minute. Okay. So, quadratic polynomial. Everybody know what is quadratic polynomial. The highest degree in a quadratic polynomial is 2. Okay. That is, it can be written in the form of ax square plus bx plus c. Okay. Where the coefficient of x square will not be equal to 0. That is a quadratic polynomial. Okay. Now, how to factorize a quadratic polynomial? So, there are two methods we can use for factorizing the quadratic polynomial. One is by splitting the middle term. That you can split the middle term. I have already taught you how to split the middle term. I will explain you again that how can you split the middle term. By splitting the middle term, you will factorize the polynomial, or by using the factor theorem. Okay, let's see by splitting the middle term. How can we use the splitting the middle term to factorize? Now, since your quadratic polynomial is written in the form of ax square plus bx plus c. Okay, now suppose that the factors of this quadratic polynomial, factors be px plus q and rx plus s. Okay, if these are the factor of the polynomial, then how can you write? Ax square plus bx plus c is equal to px plus q plus rx plus s. Okay, understood? Now, if you will px plus c, if you will change this in the form of multiply and get the PR x square plus PS plus QR x plus QS. Okay, this will be QS. Okay, understood? Now, if you will compare the coefficient, okay, x square coefficient. So, A will be equal to this, and B will be equal to this particular value, and C will be equal to this value. gx. Okay, so what you got? A will be equal to PR, B will be equal to PS plus QR, and C will be equal to QS. Okay, by comparing the coefficient, we got the value. Now, if you see that B is the sum of two numbers. Okay, B is the sum of two numbers, PS, and if you see the product of PS multiplied by QR. Okay, so it can be written as in the form of like PR. You can write as PR. Okay, you can write PR and QS. Okay, so if you see PR and QS, so it can be written as AC. Okay, the product can be written as AC. Now, this only maybe I have told you in the starting only how to split the terms. Okay, now the main concept here is that it is AX square plus BX plus C. Okay, now whenever you are splitting the middle term, okay, whenever you are splitting the middle term, then it should be the middle term should be split in such a way that the sum will give you B. Okay, the sum will give you B and the product will give you A multiplied by C, the coefficient of A multiplied by C. If the coefficient is 1, so it should give directly C. Okay, 1 multiplied by C will be, for example, I'll just explain you here. So B is the sum of, for example, two zeros are there. Alpha, it has alpha plus beta. So alpha multiplied by beta should be equal to AC. Understood this? How you are going to split the middle term, everybody? If you are splitting the middle term B, you have to see the factor of A multiplied by C. Okay, if A multiplied by C is equal to 6, for example. Okay, A multiplied by C is given you 6 and your B is 5. So you can use 2 into 3. Or if D is 7, so you can use 6, 1 as a factor. Okay, let's see how you are going to do. Once you are going to do a question, then you will understand better. Okay, now, for example, factorization of 2x square plus 7x plus 3. 2x square plus 7x plus 3. Now, here AC is equal to what? 2 into 3, everybody? Wait. AC is equal to 2 into 3. Okay, so that is 6. Okay, now, what are the factors of 6? What are the factors of 6? Factors of 6.
Ma'am, that's 1,
1, 3 to 1, 6.
3,
And 6 itself?
6.
Yeah. Now, we know the factor of 6 that are 1, 2, 3, 6. And how we got this 6 here? By multiplying the coefficient of x square and the constant term. For example, if it is written only x square plus 7x plus 3, that means the coefficient of x square is 1. So it will be 1 multiplied by 3, only 3. Okay. Now here, as we are having value of a also, so we got 6. We now check all the factors of 6. So all the factors of 6 are listed here. Now, which combination of two factors will give you 7? Okay, you will get 6 by 2 into 3, 6, or 6 ones are 6 you will get. Now, which will give you 7? 6 and 1. Okay, if you are going to add 6 and 1, it will give you 7. Okay, if it was written 5x, then you are going to use 2 and 3. Okay, don't use the term 1 and
Because 2 plus 3 is 5, right?
yeah, 2 plus 3 is 5. No, if I'm saying that instead of 7, if it is 5, then you can use 2 and 3. Don't use 1 and 2 because the multiplication should give you 7 and the addition should give you B. Okay, understood? So here it is 7, so we are going to use 6 and 1. So it will be split in the form 2x square plus 6x plus 1x plus 3. Okay, so you can take here 2x common and it will be x plus 3. And here you can take 1 common, x plus 3. So it will be x plus 3 and 2x plus 1. So this is factorized here. Okay, understood how you are going to use the splitting of middle term to factorize. Okay, okay. Now let's check the another way for factorizing. Okay, the another way for factorizing a quadratic polynomial is by using a factor theorem. Now, how can you by using a factor theorem, how can you factorize it? See, here it will be little tricky. It will become little tricky. I put the space over. Okay. Now, when you are splitting, when you're using factor theorem, what you have to do? For example, your quadratic polynomial, if your coefficient of x exists, x square, that means it is not 1. If coefficient of x square is not 1, then you need to make it 1. Okay. X square the coefficient agar 1 nahi hai, so you need to make it 1. And how can you make it 1? You can take a common. For example, if you look here in px, ax square plus bx plus c, the coefficient of x square is not 1, it is a. So you have to make it 1. So we are going to take a common. If we are taking a common, so in bx, a is not there. We cannot take common. So you are going to divide it by a. So that's here. A bracket x square plus b by ax plus c by a. So we got it in the form of a gx. We are assuming that whole this is gx. Okay. So it is AGX. Now, as we have got the value of GX, now what we have to do, the second step, what we have to do, now here if you see the constant term, so the constant term is C by A, okay? The constant term is C by A. So you need to find out all the factors of the constant term. All the factor of the constant term, that is C by A. For example, in the constant term, if you have got 4 by 5, so you have to find out all the factors of 4 by 5, okay? Now, for example, and whatever factors you get, you have to use the hit and trial method to find the 0. Okay, use trial method, find the factors at which gx is equal to 0. Okay, say x is equal to alpha and x is equal to beta are the 0. So you can further split it in this form. Okay, just let's see one question so that we can understand. Now here, example number 6, x square minus 5x plus c. Actually, this is you can say this is an easy one because you can see the factor of x in the coefficient of x square is 1. So you need not to divide it by 1. Okay, so the question is x square minus 5x plus, wait, let me see the question. X square minus 5x plus 6. Okay, this is your means this is a polynomial which you have to factorize, quadratic polynomial. Okay, now since you can see the coefficient of x square is already 1. Okay, so we need not to divide it. Okay, we'll just see the constant term, that is 6, and the factors of 6 are what? Plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Okay, these are the, in fact, plus is also a factor of 1 and minus 1 also you can take as a factor of 1. Okay, now you have to one by one check that which among these two will give px is equal to 0. Yeah, Shazan, what happened?
Ma'am, may I answer?
Yeah, tell.
Ma'am, it will be minus 2 and minus 3x. Minus 3x, minus 2x.
Yeah, it will be x minus 2, or you are saying x is equal to minus 2.
Ma'am, I'm saying that the factor, ma'am, you're going to split the middle term, minus 5x.
No,
So,
you don't have to split the middle term here. See, we are using another method, the factor theorem method. Okay, now what you have to do, you have to find all the values here, all the factors of 6 here. Now you have to check one by one. Orally, you can in the graph you can check that which is suiting the value. Okay, you have to put first plus 1 in px, and you'll see that if p1 is giving you 0 or not. Okay, so if it is giving you 0, that means it is a factor. Now here, if you check all the values, then you will get that p2 is equal to 0 and p3 will equal to 0. Okay, understood? Okay, for example, if you keep p1, okay, for example, I'm keeping p minus 1 in this equation. So what it will give you? It will give you 1 minus 5 plus 5
1 plus 5.
Yeah, so what it will give you? It is not giving you 0. Okay, that means p minus 1, not factor of px. It will be not p minus 1. We'll not write here p minus 1. We'll write here x plus 1 is not a factor of px. Okay, now since you got if you check, you'll get that p2 at p2 and p3 you'll get the value 0. That means p2, so x minus 2 and x minus 3 are the factors of the polynomial. So you can write it as x minus 2, x minus 3. So this is the factorization formula. Okay, understood? So this is the way you are going to see. If in the question it is just written to factorize. Okay, so you can choose any of the method, either the factor theorem method or the splitting middle term theorem method. Okay, splitting the middle term. But if it is mentioned in your question that use the factor theorem only, then you need to use the factor theorem. Okay, so I have told you both the way. Okay, now let's do see. Right now I have taught you the factorization of a quadratic polynomial. Okay, now let's check the.
Ma'am, can you just one more example for factor theorem method?
For factor theorem.
Yes.
Okay, wait. Let me see here. Okay, this is a cubic one. Okay, wait, I will give you one more example for the factor theorem. Just a minute. Okay, thank you for doing. Okay, see, this is another one. Okay, here. Okay, now if you see that you need to factorize x square minus 4x plus 4. Okay, if you need to factorize this polynomial. Okay, here also you can see that the coefficient of x square is not it is 1. Okay, so you need not to divide it. So the constant term is c. The constant term c here is 4. So the what do you say? The factors of 4 are plus minus 1, plus minus 2. Okay, again plus minus 2, 4, and plus minus 4. So these are the factors of this polynomial. Okay, understood? Shazan, are you here?
Yes, I'm here.
Wait. Okay. Now we need to check each and every value. Okay, you can just directly check in the rough that what should be the answer. Okay, or you can go see now. You can check that for this
Means ma'am, P plus 1 minus 1, 2 plus 1 minus 1.
See,
all.
if you will keep plus 1 here in this value. So for example, P plus 1 if you are keeping. Okay, so what it will give you? 1 square minus 4 plus 4. So what it will give you? This will cancel, 1 will still be left. If you will check for minus 1, it will give you 1 plus 4 plus 4. So again, it will be 9. So it also doesn't work. Okay, if you will put 2 P2, so what it will give you? 4 minus 8 plus 4.
Minus,
So this is going to give you 0. So see, P2 is one of the 0 of the polynomial. Okay. Now let's check P minus 2 also. Okay. This way you are going to check. Okay. You can check in rough and in the fair, you can just write the main values that are giving 0. So minus 2 if you could keep, it will not give you. Okay. Here it will give you 4, but here it will give you minus
minus 8.
plus.
No, madam, not you.
Okay. So again, it will be not equal to 0. Okay. And if you will keep 4 here, P4, so what? Okay. So you can see P2 and 2 is coming 2 times here. Okay. 2 2s are 4. Okay. So 2 times 2 are there. So you can just x plus 2. Okay. Since it is 2, so x minus 2 and x minus 2 are the factors. Okay. Understood, Shazan now?
Yes, ma'am. So this means 4 will also be the factor.
Yeah.
Now 4 will also be the factor for this.
Yeah, 4 is the factor of this. You need to check at 4, plus 4 and minus 4. See, at 4 if you will check, so 16 minus 16 plus 8 it will be there. Sorry, plus 4 here. So again it will be 4. It is not equal to 0. So this is not a factor. Okay. If you will put P minus 4, then also it is not a factor of this. Okay. And see, if you see the factor, you can see 2 is coming 2 times. Plus 2 is coming 2 times. Okay. And you can see only FP2 is giving you 0. Okay. So that means x minus 2 are the factorized form. Okay. Understood? Now I have written directly. You are going to put here. You will put, yeah, x minus 2 will be the 0. Okay, understood? You can check here how you're going to solve the questions. Okay. At x2, f2 will be 0. Okay. Hence x minus 2 and x minus 2 are the factors of the given quadratic polynomial. Now, everybody, I think time is also up. So we need to close. Okay. In the next class, I am going to finish this chapter. Factorization of cubic polynomial is left, and then we will do algebraic expression. How you can use algebraic expression to factorize your factorize your polynomial. Okay, and then we'll start the new one. Understood? Any doubt in today's class? No. Shazan, is your doubt clear now? Still not clear.
No, ma'am. I'll check, but I'll check the handout. Ma'am, it is clear, but I'll check the handout once again, so I'll get it.
Okay. If you have still any doubt, you may ask me. Okay, or message me. Okay. So. Yeah, if you have doubt in the previous question that you're asking, so you can wait for 2-3 more minutes. Yeah, Sharia?
No, ma'am, it's fine, ma'am. It's...
Okay, Sharia, what happened?
Ma'am, can you please send me the recording of the...
Yeah, recording will be there. It will be uploaded, I think, tomorrow itself, or maybe today also it can be uploaded in your app, Algebra app. It will be there. Okay, Sharia?
Okay, ma'am.
So you can check it. Okay, so till then, bye-bye. And let's see in the next class, okay?